Welcome to qnawire.
In this problem, we have to find the number of revolutions completed per minute for a centrifuge with a given radius and angular acceleration. And we know that the number of revolutions completed per unit time has a name, which is the frequency, which is a variable that we're going to need later. So the first thing that we're going to do when solving this problem is solving for v. So we know that there's an equation relating angular acceleration in v, which is alpha is v squared over r. Now we can easily solve for v, plugging in the quantities that we already know. So we find that v is equal to the square root of 6.25 times 10 cubed times 9.8, since 9.8 is equal to g, and I'm running out of room, but that's all going to be multiplied by 0.05 meters. And that quantity is the radius, which is given in centimeters in the problem, but remember, we're always going to work in units of meters per second. So when we plug that all into our calculator, we're going to find that v is equal to 55.3, and our units do in fact work out to be meters per second, so we're on the right track. Now from here, we can remember that the equation for f, or one of the equations for frequency, is that frequency is equal to 1 over the period. Now, the period can be written as 2 pi over the angular velocity omega, which is rewritten as 2 pi r over v, since omega is equal to v over r. And we just found v, and r is given in the problem, so we can solve. We get 2 times pi times 0.05 meters all over 55.3 meters per second. And when we solve this, we find that t is going to be equal to 5.68 times 10 cubed, 10 in the negative 3, my bad, seconds. But we need to remember that our frequency in the problem is given in minutes, so we are going to convert this simply by dividing by 60, which is going to give us 9.47 times 10 to the negative 5. Now all that's left to do is remember that we're not solving for a period, we're solving for frequency. And since t is equal, or f is equal to 1 over t, all we have to do is write 1 over the quantity that we just found. And that is going to give us an answer of 10,600 revolutions per minute. And that is going to be our final answer to the